Let us show that the product of two rotations is just equal to the rotation of the sum of the angles. So we are going to use here the identity identified for a rotation and show that this is really true. We know that for a rotation of a certain angle, okay, just a short review, this is equal to, we have here the cosine of theta, sine of theta, minus sine of theta, cosine of theta of a certain, okay, x sub 1 and x sub 2. But we are going to move away from the use of that, because what we just need to use here is that the formula intended for this, the product of rotations, is equal to the rotation of the sum. So let us try to look into the other form for the rotation of, let's say, let's use phi as given here. So of course we'll be using here as well phi for the angle. Okay, so you have here minus sine phi, you have cosine phi, of course the same, x sub 1, x sub 2. Okay, again, just this portion here. If you're going to multiply, okay, this is not a proof, okay, the rotation of our theta with the rotation of our phi, where we would like to show that is really true, just simply multiplying here the two different forms or matrices. You have cosine theta, sine theta, minus sine theta, and you have here cosine theta to be multiplied with cosine phi, sine phi, minus sine phi, and you have here cosine phi. Okay, so let us show it here. Since this is a 2 by 2 matrix, 2 by 2 matrix as well, their product is also a 2 by 2 matrix. Let's show that to be true. So again, multiplying matrices, you have here cosine theta times cosine phi plus negative sine theta times sine phi. Okay, that's for this and that column here. Next, for the next the entry on this column, you have here sine theta cosine phi, you have here plus cosine theta sine phi. So we have here the next one, cosine theta times negative sine phi plus negative sine theta times cosine phi. Okay, I'm going to close that here. And the last entry, you will have sine theta times negative sine phi plus cosine theta, and you will have here cosine phi. Okay, sorry, that's a phi. Okay, so with that, let me just simply rearrange and apply some operations for the rest. Cosine theta, cosine phi, this will be minus sine theta, sine phi. At the bottom, sine theta, cosine theta, phi, sorry, cosine phi plus cosine theta, sine phi. Next entry, if we're going to factor negative, what remains here would be cosine theta, sine phi plus sine theta, cosine phi. Okay, so that's it for this portion. And here you also have, going to start writing this, okay, just to be similar to this entry here. So I will have cosine theta cosine phi minus sine theta sine phi. The next part here is, of course, looking into the identities in trigonometry, especially the sum and addition formulas. Okay, so with that here, this is actually cosine and sine. By the way, this is the other one, should be phi. Okay, this is actually the cosine of the sum theta and phi. Review your trigonometric identities. This one here is sine theta plus phi. Here you have negative of, take note, you have this similar to that, and this anti-similar to this. But this is actually just negative of your sine theta plus phi. At the bottom, you will have cosine theta plus phi. With all of this already recorded, if we're going to take this as one angle, okay, this is similar to this form here. Okay, just the rotation, but our angle is the sum. This is equal to the rotation of the angle theta plus phi. This is now the proof that the identity is just the same. When we try to come up with the product of two rotations, it's just the rotation of the sum of the two angles. Thank you very much for watching.